this video, I will let you know how a small school level concept benefited the entire field of science. And before moving forward, let me tell you, Make Science in Seconds will provide you with shorter and simpler videos that will empower the science learner in you. Subscribe to our channel and check out our other videos to learn more science related contents in seconds. Consider a system of gas. Picture that gas molecules consist of billions of molecules moving rapidly at random, colliding with each other and with the walls of the container. The molecules are like spheres with a diameter much smaller than the distance traveled by them. Also consider the molecules move between collisions without interacting each other at a constant speed in a straight line. But I repeat, positions and velocities of the molecules are initially at random, despite the fact that they maintain a constant speed in a straight line between collisions. This also implies that the velocities of molecules could change after the collisions since they exchange energy during the collisions. Now look at the number of molecules. They count up to billions, which implies it is very difficult or nearly impossible to compute the motion of an individual particle. Look ridiculous when you write it down. This toughest problem can be solved using the simplest mathematical tool: averaging. Calculating averages using mathematical tools could provide us with a lot of information. It could tell us the probable velocity distribution of molecules, or another way, the range of velocities of molecules, which means the molecules are moving with uniform speed between collisions within this range of velocities but with no preferred direction in space and are independent of each other. This idea seems similar but could provide us with a lot of information. I am not going to detail what all information we would get from this, but the concern is, what if we could calculate the probability that a molecule chosen at random would have a particular velocity? This is nothing but Maxwell distribution. Heating causes the molecules to move faster and collide with the walls of the container more frequently. This would give us a different distribution at a different temperature, but still we could compute the probability that a molecule chosen at random would have a particular velocity. Realize the fact that there wasn't any advanced computing system then, but still Maxwell found out a way using a simple mathematical concept to get the information on a billions of molecules. Sometimes the problems in science seem complex, but the solutions are much simpler.